Okay. Okay. All right. Great. Great to see so many people logged in. I can see quite a few people on the YouTube live stream as well. Okay. Hi, everyone. I hope you're able to see my screen and also see see my video. Great, great. So you can use the Q&A window to ask questions. And yeah. All right. All right. So it's going to be a 2-hour session with 10 minutes break. Except for myself, everybody will be on mute. And we're going to use Q&A and chat to ask questions. And the recordings and the slides will be made available after the session. Okay. All right. About myself, I'm Sandeep Giri. I did graduate from IIT Roorkee long back. Then I worked on large-scale computing and machine learning at Amazon, InMobi, and DE. And I love explaining technology. And at the heart, I'm a software engineer. So great. All right. So at CloudxLab, our core vision is to upskill engineers and IT professionals in deep tech and machine learning. And basically, we in the domain of deep learning, machine learning, and big data, we make people employable and future ready. Now, one of the signature things about CloudxLab is that the playground, whereby you will see the prompt statement on the left-hand side, there'll be an editor on the right-hand side. And when you submit an answer, it'll show a message saying good work. And basically, this is problem. And here you'll have to solve it. And once you have solved it, you can just submit an answer. Okay. Then you'll see the console. You can access the console from anywhere. Okay, you can just go to the terminal and start using it. All the technologies, all the tools are accessible from there. It gives you a dedicated workspace where you can start using it. Okay. It's a cloud-based lab. We have a online lab, which is basically like the real world. And it provides you a seamless experience, centralized data set, and any device anywhere can connect to it. Apart from that, it provides you to build your social profile. Whatever work you're finishing, that'll be visible on your profile. You can connect with other people and so on. And of course, there is a dedicated job portal. There is a placement eligibility test. Now, one of the very important discussion that is going around the world today is the large language model, or LLMs, right? Specifically, after ChatGPT became successful, the entire world has started moving to the large language models. Okay. So today part of our discussion is going to be in understanding how exactly large language models work. And then we basically try to understand exactly what's beneath the large language models. Okay. So, all right. Feel free to ask questions as and when needed, and I would love to answer. So large language models are state-of-the-art AI models designed for processing and generating text. Okay. So in simple words, these machine learning models are pretty large ones, and they handle the text. I will come back to the point to how and exactly where. They are probably the best in the history of mankind in understanding language and generating the language. So as of today, we know very well that ChatGPT would be the most intelligent system, or any large language model. There are something from like Google, Bard, and so on. They're also large language models. Okay. They are probably the most intelligent AI that we have designed so far. Okay. So it possesses the contextual awareness. It is trained on large data set, making them really, really intelligent, and they basically understand a lot of words, a lot of sentences, the meanings, and so on. It has revolutionized the industry by several means, such as customer service, content generation, language translation, and virtual assistant, and more. Now, right now, so the NLP model, going back, so large language models are basically natural language processing models, right? They process the language and so on. They generate human-like response. Now, I think a better way is to look at what ChatGPT does. So you can actually just go to ChatGPT and try. Okay. Who all have tried ChatGPT so far? Please raise your hand if you've tried ChatGPT so far. Okay. Okay. Only 10 people have tried ChatGPT so far. Okay. Interesting. Interesting. Okay. If you have not tried, you must try. I can show you briefly. Okay. Right. Or you can try Google Bard. Google Bard doesn't work in the territories where I am right now. Okay. You can ask any question. Okay. You can even ask it to code it. You can basically ask any question and it will answer that question. Okay. Okay. So you can try. Yeah. Here you can ask, right? Okay. So I just asked, what is 1 equals 1? Okay. All right. Do you notice multiple things that it generates word by word or letter by letter? We'll come back to that. Okay. Now, let's move on. So it essentially has the ability to understand question and answer. Nobody, now the amazing part about ChatGPT is that nobody coded it as such. Okay. Nobody coded it like sentence by sentence or word by word. I'm going to talk about how to leverage it and how it works. Okay. So the next thing is next question could be write a rap song related to programming. Okay. Now it can generate the song as well, right? It can generate the code. It can generate the database schema. It can it can generate the function calls and so on. Now, the question is, how does the machine learn? Okay, how does the machine learn? So that's the first question that is there in everybody's mind, that how was the ChatGPT built? Okay, how exactly the ChatGPT built? But before going there, we need to understand how exactly does the machine learn? Okay, those who are already aware, right? They would know. So most of the, like, we will focus a machine learning algorithm or a strategy called neural network. Most of the neural networks are inspired by structure of brain. You feed the input and there is an output, right? So you can think of the entire neural network to be connections, and these connections are knobs. These knobs, they're not neuron, they're connections, right? So these connections translate the input to an output. And these connections is basically you have to tweak. These knobs you have to tweak. Now, there is usually the two phases of any neural network or any machine learning model. One is a training phase, whereby when you input and there's an output, these knobs we tweak, they basically, like, you must have seen the bathroom taps, right? When you tweak those knobs, the temperature or the temperature of the output water changes, right? When you mix and match, there's a cold water, hot water, you are twisting those knobs and the different temperature water comes, right? So basically, in the same way, think of a billion knobs that translate the input into output. Okay. Now, these knobs need to be trained. We need to figure out that good position of a knob that is giving us an output. Just like while taking bath, you twist the knob, and you note down the positions, or mentally make a note of all the position of both the knobs, hot water and cold water, such that while taking bath, you can be sure that this is the location which gives you the perfect water. So there are two phases when you're taking bath. Number one, you try to figure out what is the best position of knobs, which gives you good water. And this phase is called training phase, where this is a discovery phase. You twist the knob, it goes hot, you turn to the colder side, and you keep on doing that over and over, right? And after a while, you settle down at a point where you say that, okay, this is the good position for water. That means you have found those positions, and this position is called, this entire phase is called training phase. Okay, and the position of knobs is basically the model, the location of knob, how much you have twisted each knob is called the model. In the same way, you can visualize the neural network that we have lots of input and expected output, right? We have lots of input and expected output. Now, in order to match the output to the expected output while we feed the input, we need to twist these knobs, right? And the neural network is nothing but, say, billions of knobs. The computer, the powerful computer, would twist these knobs and figure out what is that perfect position of knobs that gives us the output. This perfect position of knobs is called trained model. And this phase is called training phase. Okay, I hope you are able to visualize. I hope you guys are able to take the analogy of taking bath with the neural network. No? So, yeah. So when we say training phase, right? So when we say training phase is essentially the phase where we translate the input into output. Okay, sorry, we learn the positions of the weights, or you can say knobs. Okay, so we arrange the way we can think of this neural network is, we took like billions of knobs, put them here, and then twisting them. Now, these knobs, they may look like mechanical parts, but they are essentially numbers. Okay, so when we say this water will go through this knob, essentially, this input is getting multiplied with this weight and going up, right? And then the output is getting multiplied again and again and so on. And then we get output. So all of these inputs get multiplied with these weights and then summed up, and we basically do some more magic here, and then we take it out. So this phase is called the training phase. In the training phase, we discover this phase is also called optimization phase, or you can say backpropagation, gradient descent. Those are the algorithms which greedily twist these knobs. As in, we slightly twist it to the right, observe if the output is matching the actual output. If not, we turn it to the other side. Okay, and we do that greedily, so that we can quickly optimize or figure out those perfect positions of knobs. Okay, taking analogy of neural network with bundle of knobs is probably the easiest way you can think. Knobs as in like the tap, when we take bath in the shower, right? We twist those knobs, right? That handle, we twist it to the left and right. So that's what I'm calling knob. Okay. Now, the next phase of any machine learning model is inference phase. In this phase, you do not have expected output, and you're only giving the input. So you take the input, you feed it to the model, and it gives the output. So this way, the inference happens. Okay. So in inference phase, what we usually do is we take the input and it translates that to output. Okay. And this is an unseen, this is the phase where when we use ChatGPT as is, this is the phase where we are. Okay. Now, the question is, all of this seems okay and common sense, like there's a training phase and there is a inference phase. In the training phase, we figure out the model, we figure out the weights. I used the term knob for the weights. We twist these knobs and figure out what's the good position of these knobs such that our input results in the output. Now, in the inference phase, okay, let me go back a step. So there are two phases. One is training phase and other is the inference phase. I'm sure that all of you are comfortable with these two phases. Now, in the similar way, this same thing is a bit different represented in this diagram, right? The same neural network, right, represented in this way. This is more common way of representing neural network. There is inputs. This is neuron. And these lines that you see is what I refer to as knob. Okay. Though this one is round, okay, this looks like a knob, but no, that's not the knob. These are connecting points. When we are training a neural network, we are tweaking these connections. So we feed the input. This is the input neuron. From the input neuron, the output goes to other layer of neurons, and there are hundreds of thousands of such layers. And then there is an output here. Okay. So this is called a neuron, whereby there are lots of inputs that are reaching here. Let's say this one, and it is merging it here. Okay. Merging usually happens after summation, summing up all these values, and then we apply some more mathematical transformations. So input multiplied by the weight, input multiplied by the weight. Weight is this number, you see this number, this knob that I talked about. Okay. So the neural network is nothing but these lines, you see, these connecting lines that connect input to the output. Okay. So input get multiplied with the weights, and that all summed up here. And then there's a mathematical translation called the activation function. And after that, it goes to the next layer and next layer and next layer. Okay. So neural network is essentially this sort of structure, mathematical formulation, which basically works on this principle. Okay. All right. So we are clear about how does a neural network work. And any questions so far? I have basically gone very high level just to give everybody the perspective of what is going on. Okay. All right. All right. Even if you don't get this diagram, it's okay if you get this, right? That there's input, there's expected output. We tweak these weights or this magic black box, the knobs inside this magical black box, such that the input results in the output. Okay. Now, all right. Now, question is, all of this sounds great when we talk about numbers, right? Okay. All of this sounds great when we talk about numbers. Okay. Okay. Now, what do we do in case of text? Let me get back to that question. Before there is an answer. Can you explain why do we multiply weights with the input and the formula? So basically, the way you should look at it is this, that, you know, right? This input gets multiplied. These are the weights, W1, W2, W3, and we multiply this input with W1, this input with some other number like that. And then whatever is the value, we basically sum it here and then do the activation function on top of it. Okay. You can take a look at, you know, the internet for exact formula. I mean, if I include the formula right now, everybody will be bored. Or you can, you know, reach out to me later for exact formula. Okay. Now, moving on. All right. All right. Now, so we understood that when we feed numbers to it, it gives numbers as output. Okay. We feed numbers, it gives numbers. This number is basically the features, right? This is Y, this is X. When you feed X, it gives Y, right? So this is like an input variable. This is an output variable. All right. So those are the other ways to look at it. Now, the question is, how does this thing gives out word? Number seems to be okay, but how does it give out the word, right? Simple. We give the ID to every word, or sometimes in some of the models,
we give the ID to every character. Okay. So we convert the input to tokens. We call that IDs or tokens, and then translate this token into an array. If you have, let's say, 10,000, total 10,000 words dictionary, this will get translated into 10,000 numbers. And out of those 10,000 numbers, everything except one is one, rest are zeros. Okay. Similarly, this one. So it'll get translated into an array whereby everything will be zero except for the cat, that will be one. So you can think of this as a Excel sheet, right? We are feeding the cat and the dog in the form of an Excel sheet, where the columns of this Excel sheet are each word from the dictionary, okay? And each row represents the word from the sentence, okay? And in each cell of the Excel sheet, we have marked as one, okay? Wherever the word appeared. So that's how we feed the input to the neural network. Essentially, neural networks understand the numbers, not the language. So we have to translate the language so that we have to translate the language into numbers so that neural network can handle it, right? So we translate the text like the into a number, cat into a number, and so on. And then further, we translated this 5 to 1 into basically a big matrix whereby only the fifth, like for example, to represent cat, only the fifth word will be marked as 1, rest will be marked as 0. Okay, so it'll be like 0, 0, 0, 0, 5, 0, 0, 0, something, right? Like 0, 0, 0, 0, 1, and then 0, 0, like that. So it'll turn it into an array. Okay, and then we feed it. A neural network, instead of printing the text, what it will give? It will give the probabilities. Okay, if our total number of words is 10,000, so this array that represents the will be of 10,000 size. Okay, and everything in this array that represents the will be 0 except for the word the that is marked as 1. Now, neural network will give out 10,000 probabilities. Okay, the probability of first word, second word, third word, and so on. And that way, it will basically give out that way we will pick the one that is most popular here, and we will mark that as the correct word. Okay, so for example, fourth word has got 0.85 probability, and fourth word is basically play. Okay, the cat and the dog play. Okay, so it's giving out the next word. Okay, now neural network, the way ChatGPT was first trained on auto completion. We basically trained ChatGPT to do the auto completion, right? Given a phrase, predict the next word. Given a sentence, predict the next word. That's how the ChatGPT had been trained. Okay. And essentially, the ChatGPT in the first version was nothing but auto completion tool. Just like your Android keyboard, it was just auto completing. Okay. Now also it's actually auto completing. When you put the question, it gives a next word and the next word and the next word and the next word. Okay. So that's now also it's auto completing. Just that it has been highly fine-tuned. Okay. So now I hope everybody is clear that how a neural network consumes a set of words and how it gives out a word, right? While feeding the word, we convert it into one hot encoded vector, or you can say an array in which only the particular word is marked, rest are all zeros, so that this whole array, each word will be represented by same size of array. 10,000 numbers, 10,000 numbers, 10,000 numbers, and so on, right? And only everything will be zero except for that word. Okay. So now, and it will also give out a bunch of like 10,000 numbers. If 10,000 is the total number of words that you're dealing with, then this. Okay. Now, moving ahead. All right. Okay. So our question is how to translate. Do we have any specific programming that converts it? Arijit, what do you mean by specific? I did not. Which translate are you talking about? Like how does the ChatGPT does translation, like English to Hindi, Hindi to some other language or so? Is that your question? Question is, okay, question from Arijit is how does it translate? How does it translate the input to token, right? So it is very simple. We have given numbers to each of the word, okay? The token and those numbers get translated into one hot encoded vectors, right? Like, what does it mean is that, this will be, okay, first one is 1, rest are 0, okay, something like this, okay. Here, the fifth one, okay, sorry, this will be 0, only fifth one will be 1. Something like this. Of course, this will be like 10,000 numbers, not like only 5. Okay, this will be 10,000 numbers, not only 5. Okay, now in this case, it will be 0, 1, 0, 0, 0. Okay, here again, it is same word 1, 0, 0, 0, 0. Okay, this will get translated into 1. Okay, of course, it's zero-based index, so there's a bit of there are bit of inaccuracies in the explanations, but never mind, those are all fine. Okay, so you can see that we converted each of these numbers into this, and this also gave us, say, 10,000 numbers containing probabilities, and we picked the ones that are more popular. Okay, I hope that answers your question. All right, you can use chat to reply. Okay. All right, so that's how the translation happens. Now, so this way it produces the output. So the way ChatGPT has been trained, the first model was, we call that GPT, right? Generative pre-trained transformer. The transformers are basically a type of neural network. The internals of the neural network, this bunch of knobs that we talked about, the internals of it, right? Basically, the transformers is something that has made it possible to handle a lot of complexity in neural networks. So the partial credit of ChatGPT being in existence is because of the transformer models. Okay. And one more question at this point is 10,000 numbers are max. No, it's up to you. How many tokens do you design? Okay. And that's not the number of tokens as such. Basically the 10,000 I said was 10,000 numbers is in 10,000 numbers dictionary I was talking about. All right. if you're dealing character by character, the number of tokens will be different, number of dictionary size will be different, and so on. I just took an example to put my point across. Perfect. Moving on. So what it did, what people like, if you look at ChatGPT carefully, it's actually a pretty simple system, right? To understand from the high level, right? So first, what people did was they made something called GPT. Okay, what GPT did was it took one word. So what they did was they took the entire internet data, and then asked the neural network to predict the next word given bunch of words, right? So we fed, like, first, let's say that's the sentence that we have is the cat and the dog play, right? So we first fed the, ask it to produce the cat, tweak the models, we twisted the knobs, then we fed the cat and expected it to give out and twisted the knob again, and then we said the cat, and we again twisted the knobs and like convinced it to produce the, and we kept on doing it over and over, and for all the sentence and everything. So the positions of the knob were such that they became more and more precise while giving the result. So the bigger you have the sentence, the better you get answers. And this is when the right GPT model became very popular, and people started doing all sorts of crazy things with it. And OpenAI further went ahead, and what they did was they increased the size of the model, made it more and more complex. And then they came up with something called Q&A model, whereby there is something called end of the question. Okay, end of the question is again another token or another word. And the moment the ChatGPT encounters an end of the token, it starts producing outcome. Okay, so you can see that ChatGPT is basically still the autocomplete model and so on. Now, they also did a couple of very interesting things. One of them is that they asked ChatGPT to produce multiple answers, right? Multiple answers. And then human rated all those answers and then fine-tuned this model to produce only the one that was highly rated. Okay, so this again became very interesting because this way the model learned from human feedback. We also call it the RLHF, reinforcement learning using human feedback. Okay, so this is right now the question. So I hope everybody is clear about how does the neural network work. There's a training phase, there's an inference phase, and then how it learns by twisting these weights, changing these weights in certain clever fashion, and that algorithm is called gradient descent and backpropagation. And then it basically gives out the next word and so on. And now, with this, let's learn about how to utilize ChatGPT and LLMs in your favor. Okay, so there are two clever ways of using or utilizing LLMs, right? LLMs produce two kind of things. Number one, given a text, it produces the text response or a reply or an autocomplete, right? So you give the text and it generates the further answer to it, right? There is a second thing which is very, very interesting. It produces something called sentence embedding. Okay, what is a sentence embedding? okay, or language embedding, or sometimes referred to as word embedding, and sometimes embedding vector and vector embedding. So those are the words or phrases used for this. Okay. All right. So this sentence embedding is not same as what we talked about earlier, right? This one, right? No. These word embeddings or sentence embeddings are trained on like in a similar fashion, okay, such that the two texts which are similar should produce sentence embeddings which are closer to each other. Okay, and these sentence embeddings are bunch of numbers. These are basically bunch of numbers. And okay, so if let's say we feed, right, we feed I am Sandeep, and it produced bunch of numbers, and when we plotted these bunch of numbers onto 3D, let's say onto 2D, let's say this is I am Sandeep. Okay, now this is first sentence. Okay, I'll just mark it 1. Okay, this is 1. All right, now we fed the second sentence, and the second sentence is called my name is Sandeep. Okay, now this is, let's say, 2. Okay, 2, and here, okay, so they're basically very close by here. Okay, my name is Sandeep, and I am Sandeep. They're very close by, but the third sentence, okay, the third sentence like this, I am a person. Okay, now again, this is a bit, this is bit farther away from I'm Sandeep and my name is Sandeep, because these two sentences are close by, and this is a bit different one. Okay, and then, right, cow eats grass. Okay, now this sentence is way away from both of them, correct? So that's why now, so to represent this particular data point in 2-dimensional, you need 2 numbers, right? 2 numbers. So in large language models, they translate a language into around 1,000 numbers. Okay, so the same thing that I'm trying to represent here, same thing happens in 1,000 dimensions. Okay, basically, the sentences which are similar would be close by. The sentences which are very dissimilar, they'll be farther away. And further dissimilar, which has no relation, they'll be even further. Okay, so essentially, this is an amazing tool to do lots of logic. Like, for example, you have got Android reviews, right? And you want to find out which of these reviews are similar. So what you will do, take each review from your Android app store and translate that review into embeddings. Embeddings are nothing but a array of numbers or vector of numbers, bunch of numbers, okay? Or you can say coordinates, okay? Now, once you got these embeddings, then you go through these embeddings and try to group them together using some of the algorithms, okay? Or you can just iterate over this and find out which of these are closest to each other, okay? And this way you can figure out which of these reviews are duplicate, and so on. So there are many use cases of, each of them. First approach is use the large language model to generate text, right? Second approach or strategy is use large language models to give out sentence embedding, right? This is text, this is numbers, okay? Now, when you are generating text to text, there are many use cases. One is rephrasing text. This can also generate SQL. So you can give the schema as part of your, prompt. It will generate the SQL schema. You can ask it to generate SQL. Not a schema, it will generate the SQL. Okay. So if you want to make your own Siri for your organization, you can use ChatGPT. You can say that these are the tables in my database. Can you translate this particular question into a query? And it will generate that. And it is quite powerful. It can also generate mappings, as in you can give it two lists of, let's say you give it a list of, let's say name, you want to autofill forms on internet, right? So what you can do is you can give it your name, first name, last name, and you can give it, say, phone number and address and so on. And then you can ask it to generate other things, like generate my full name. Okay, so you can do sort of a mapping generation. And this is quite useful where you have to autofill the forms and other things. Then you can do translation, one language to another. You can do summarization, given a large text. You can ask ChatGPT to summarize it in a line, a paragraph, and so on. You can do content creation. You can give it a detailed topic, and it will generate the content for you. You can call APIs. You can tell ChatGPT that, or any of these large language models, that these are my function spec, and can you generate a function call? And there are many more use cases. So text-to-text translation has got many uses. Okay. All right. Now, the other way is the embedding. Okay. Embedding, as I said, is nothing but a bunch of numbers. You enter the text, give it to the model generates the embeddings. You can take a look at the open source a library called LangChain. And the other thing that you can do is you can take a look at the OpenAI documentation about the same. Okay. Now, essentially, when you are entering the text, if this is the vector that is getting generated, if you plot this data, like this is multidimensional, of course, but you can try to visualize it in this way. If it was two-dimensional, this is how it will look like. Okay. So canine companions say woof, right? These are very close to each other, right? Bovine buddies say moo. Okay. Feline friends say meow. Okay, so these are very close to each other. These are very close to each other, while this sentence is far away from each of them. Okay, so basically similar things end up close to each other. And if you want to find out if something is similar, you can basically translate that into embedding and then do the calculation. Okay, how do you do the calculation? How do you find the distance? Remember Pythagoras distance? A minus b square plus c minus d square and then square root, right? That's how. Okay. Or you can say x1 minus x2 square plus y1 minus y2 square and square root of the total. Correct? In the same way, multidimensional, you just say x1 minus x2, y1 minus y2, z1 minus z2, and so on. Keep on doing that. Okay. So the similar presentation, again,
you can take the text, translate it into embedding, and then you can plot it, right? So you can see that here, this dark means those sentences are very similar. So how old are you? How old are you are very similar. Okay, when we computed the distance between each of them against each of them, when we computed the distance of the embedding of how old are you with how old are you, it came as 0. So there is overlap. Between how old are you and what is your age, this is also very similar, right? Now, how old are you and my phone is good, this is far away, right? Lighter. So, and so on. Similarly, my phone is good and my phone is good and your cell phone looks great. They are overlapping, correct? The distance between this embedding and this embedding is very close by. Okay, that's why you see this colored, not light colored. Okay, so this is very interesting. If you say you take a bunch of sentences and try to find distance from each of them against each of them, you can figure out which of the sentences are similar, right? I like my cell phone is good, not good, my cell phone looks great, right? They are close by, not same, close by. Okay, using this strategy of embedding, you can achieve a lot, right? Using embedding, you can do machine learning. What is machine learning? You can train another model on these bunch of numbers, right? Because our machine learning models work on numbers, right? Work on numbers. And these numbers make a lot of sense. Now, you might say that why not I use one-hot encoding for instead of this, right? The tokens that we generated and translated them into numbers. Why don't we use that? That one basically will not give you great result because it's not really, it's basically raw. There is no knowledge. There is no significance of that. Here, there's a significance of these numbers. Okay. The numbers that are close by are very, very similar. Okay. Now, so you can do machine learning on top of it. Let's say you want to train and build your toxic text classifier. So you can train another model and design that, right? On the other hand, you could do the normal k nearest neighbor. What is k nearest neighbor? Finding which are close by. Okay. K, if you want to find out k close by points to one point, it's essentially a for loop. So you iterate over the entire data set and list down or narrow down on the k nearest data point of one. Okay. So using k nearest neighbor, you can do semantic search, meaning find the meaningful answer. So you basically, if somebody asked a question, you go over all the questions which are similar to this question using the k nearest neighbor search, and then pick the one that is most meaningful, most closest. So you can build a search engine using the embedding. Now you can build a chatbot. Okay, you can do a key knowledge base article recommendation. When somebody is asking a question, you can find out which one is closest, right? Next is you can, right? You can build recommendation engine. Okay, in general, like suggest items based on semantic similarity. Then you can do zero-shot classification. You can just say that which of these sentences, like you can just compare the embedding whether it's closest to negative word or positive word. So you find out the embedding of negative, you find out the embedding of positive, and whatever sentence somebody gives, convert that into embedding and find out the distance between this word and negative and this word and positive, and figure out whether this word is closer to positive or negative. This sentence is closer to negative or positive, right? That's called zero-shot classification. Then you can do code search using embedding. So whatever code somebody has typed, you can just do convert that code as well into embedding and go through the entire system to figure out which code is similar to this piece of code. Okay, all of this is possible by doing maths around doing basically the search around the embeddings. All right. Similarly, you can do supervised, unsupervised regression classification on the embeddings. Okay. And of course, clustering and so on. Like, for example, I'm taking an example. Imagine that you want to find out the ratings. Okay. So what you'll say is you will pick the reviews by various customer, feed it to the LLM. LLMs gives you as embedding. Then we create a regression model on top of embedding, and that will predict the ratings. Okay. So this one is an inference phase. This one will be in a training phase and then inference phase. Okay. So similarly, we can use embeddings to translate a document. Like, you can classify the documents into various buckets. Okay. You can say, you can imagine that we have the embeddings of documents. Okay. And we have so many, like all the documents we have converted that into embedding. And then we train a model, which basically translate an embedding into whether that is related to clothing, camera, or house appliances. Okay. Similarly, in the same way, you can translate an embedding into unsupervised machine learning, right? You can, in other words, you can say that you can utilize embeddings to do unsupervised machine learning, such as clustering. So what you can do is take all the sentences of people, the percentage of all the words, plot them, and then do the clustering. Or even without plotting, you can apply the algorithms such as k-means and so on, and figure out which belong together. In this example, we discovered 4 distinct clusters. One focusing on dog food, other on negative reviews, and other on positive reviews. So this is from Amazon reviews. Okay. Okay. All right. So Kiran is asking to show the previous slide once more. Do you mean this one or this one? Okay. Here, there is a training phase. First, you have the embedding and the ratings of the various reviews. And so we train this regression model. And once we have done that, then once we have trained it, then we can, any text, we can predict the rating. Okay. All right. So with the embeddings, you can do a lot of build models and do lots of prediction. Okay. Okay. Now, a quick question that people have is how to customize LLMs to build our own application. These parts, most of them are done via these parts. I'll go back. Not this one. Okay. Yeah. So this text response part mostly is done via a library called LangChain. Okay. So you can try LangChain. So basically, LangChain takes language learning to the next level by integrating large language model. LLMs such as GPT-3 have the ability to generate human-like text and provide contextually relevant responses. LangChain harnesses the power of LLMs
to create advanced generative AI and chatbots. Okay. And it can connect your LLM to your data using vector database. What is a vector database? Basically, when we are looking up for embeddings, one way is that we compare the embeddings with what we already have in our database. That is going to be very slow if you just go one by one. What vector databases have done is the existing embeddings of all the languages and objects, you can put them in vector database so that it can look up based on embedding very quickly. So that's a vector database. So you can utilize the LangChain and the various kinds of vector databases to build your personal assistants and question answering over documents and creating your chatbots. Okay. Now, okay, you can create your own agent and you can also query data from CSV file and so on. So interacting with OpenAI has been very made easy by LangChain. It also makes sure that tomorrow, if you are moving away from OpenAI, let's say you are going to use Google Bard, you can simply swap it. Okay, so LangChain serves as a mediation layer between various systems. Okay, so it simplifies the evaluation of generative models by utilizing prompts and chains within the language models. Okay, how is GPT revolutionizing industries today? Okay, GPT can be used to generate text content for website, blogs, and social media posts. By giving it a prompt, such as a topic or a keyword, it can generate human quality, human-like content, very high quality. Okay. Okay. So, all right. So it can do the translation, like human level translation. Okay. There are few downsides that you should know about ChatGPT. Number one, it is difficult for it to not lie. It might lie at some time. Okay, I'll talk about that soon. Okay. So GPT can be used for summarization. Okay. So you can summarize the entire book. One of the clever hacks of life is if you want to know what the book talks about, let's say you have been lazy and people have been talking about that you should go for, where is that? Yeah, yeah. Okay. Let's say, where is that? Okay. Say you want to summarize a book named Atomic Habits. Okay. All right. So you can see that it has simply summarized the entire book in a couple of paragraphs. Okay. So you can utilize it in many ways in your favor. All right. You can make it write the entire story. Okay. Okay. So question answering systems you can build around it. Like, will CloudxLab be good for me for learning machine learning and artificial intelligence? What else CloudxLab offers? Okay. So it has given the entire overview really well. So it understands CloudxLab. Okay. So GPT can be used to provide personalized recommendation and content based on user behavior and preference. Okay. So you can actually ask, you know, it can give you the movie recommendations as well. Okay. All right.
Okay, so one of the questions is, will AI replace software engineers, data analysts, and data scientists? No, it has made it more and more relevant, right? More and more engineers are needed to build solutions around GPT, large language models. That's why lots of people are opting for courses like the one that we are offering at CloudxLab. You can, this course is about machine learning, deep learning, and large language models. Okay, so you can basically sign up for that. It is high time that we all basically get ourselves updated. As I said previously, that the it's ChatGPT is not only about text output, it's also about machine learning. Okay, so if you utilize or you build machine learning models on top of embeddings and ChatGPT, you can do wonders. And that's why there is so much hubbub. Most of the industries are inventing, existing companies are reinventing themselves. The companies that built analytics UIs, they are introducing ChatGPT based auto generation of SQL. The companies that were focused on human input for the workflow design, all of that workflow is being generated and designed by LLMs. Similarly, code completion, you know, building the boilerplate code and so on is being generated by AI. So we need software engineers, analysts, and data scientists or AI engineers in order to, number one, utilize GPT to solve a business problem. Number two, to invent new similar models. Okay, so it is very imperative that right, because software engineer does not really do a repetitive work. They solve business problem. If somebody was doing repetitive work, their job must have been obsolete by now in software engineering, because another script will make any repetitive work automated. So in software engineering, most of the work is usually non-repetitive. Okay. Therefore, if you guys upskill, if the software engineers upskill themselves to embrace the machine learning and large language models, it will improve their career. And that's true for almost everybody. Okay. Question from Nista is, better ask, will AI replace? Sorry, my water spilled over the thing. Okay. All right. You guys can ask questions. I'll take a quick break because there's a lot of my water bottle spilled over my carpet. So just ask questions. I'll be back in 2 minutes. All right, so I'm back. Just give me a moment. All right. So question from Gujaya is that, can I build chatbot for 1 GB of data using LLM LangChain? I have built it using GPT 3.5, OpenAI, used LangChain, but I'm facing issue with OpenAI token limit. Good question. Good question. So if you can see, the main problem with the ChatGPT is that there is a token limit. As in, when I'm asking a question to ChatGPT, I can only ask a smaller question. I cannot ask, let's say, 1 GB size question. So what do we do in such case? So you have to cleverly do a bit of engineering. Like, for example, if you're trying to answer a question by customer, so instead of feeding ChatGPT the entire of the website that answer this question based on this data, instead of that, you break the website into pages. And then for each page, you generate embedding. And for the question by the customer, you generate embedding. And then find the nearest paragraphs and ask ChatGPT, can you answer this question based on these paragraphs? Okay, so that's exactly what the engineering is all about. So take a look at LangChain and you'll be able to figure that out. Okay, and by the way, I'm launching an open source project about the same so that you can quickly build your chatbot without too much of content. Okay, a question is, I suppose it can speed up tasks such as making presentations, writing queries, etc. Yes, of course. And the content has to be reviewed by humans. Yes. Thank you. All right. So great, great. Wonderful to have all of you in this session. We have launched this PG certificate course in AI, machine learning, and data science. It includes large language models and the vector databases, prompt engineering, LangChain, stable diffusion as part of the course. So, and the certificate is by IIT Roorkee. There will be a campus immersion and so on. So feel free to sign up for the course. There are only few seats left. Okay, so you can take a look at the course and reach out to me. Okay, so, and for any questions or doubts, reach out to us at reachus@CloudxLab.com. Okay. A question from Arijit is that, maybe upload the documents in ChatGPT for answers? Not really. It doesn't work that way. Okay. All right. Thank you, everyone, and have a good day. Any other questions before we take a break? I mean, we call it a day. Okay. This was a brief overview aimed at everybody who is very new to the technology. And I wanted to give an overview of the technologies. All right. Thank you, Saeed. And yeah, feel free to reach out to us at any point of time. Also, please fill in the feedback form given by Tejveer. I'll just share again. Okay. All right, everyone. Please fill the feedback form. Okay. And you'll get the, if you fill, like, please fill the form so that you can get the participation certificate as well. Okay. All right, everyone. Yeah. Thank you so much and have a good day. Bye-bye.